Here we go. We have a question, triplet family. So you have given an array of integers. We need to find whether three numbers are such that the sum of two numbers is equal to the third element. So in this case, 1 and 2 is equal to 3. So we need to return true. In this case, no triplet satisfy the condition. So we need to return false. The expected time complexity is n square and expected space complexity is constant. So it is pretty clear what we want to do. So let's try to build the approach. We have this test case. So the expected time complexity is n square. So first of all, we need to sort this 1, 2, 3, 4, and 5. After sorting, before sorting, we can solve this question in order of n cube simply with constant space, but we want to solve in order of n square. So now we have this. In this case, we can simply find two numbers is equal to the third number. How? So let's set I to this number, and we need to find two numbers. We need to find two numbers in left hand side whether two numbers is present whose summation is equal to the third number is equal to the ith number. So let's set L to this and R to this. Is this summation is equal to I? Yes. So let me change the digit. Let me change the value here. So suppose value is 15. Now is L and R summation is equal to I? No, it is not. This summation is less than element of I. So we need to increment. So what we want to do? We just simply need to increment L. Now, is this summation is equal to this number? No, still answer is no. So we still need to improve L. So now, is it equal to I? Still, it is not. So we need to increment I. But now L and R is pointing to the same number. So we just get out of the while loop. Now we need to find another number. We will decrement our I. L here, R here. Is L and R equal to I? In this case, yes. So in this case, we will return true. But for explanation, let me change the number. So let's take 6 or 7 here. Let's take 7. So now this and this summation is not equal to 7. We need to increment L. This and this summation is also not equal to 7. We still need to increment L. Now still, sorry, L and R point to same number. So this is not valid. So we need to decrement L. We need to decrement I. So this is the last position. I can go. I can go from n minus 1 to 2. Only 2. Because we need two digits. This is the last index. This is the last index. So L here, R here. Is the summation is equal to? Is the summation is equal to element of I? Yes. So we will return true. So you got it. So let me code this. Code is simple. So let's continue here. We have to sort the array. Then we need to find the length. The I will point to n minus 1 and can go till 2 only. We have left and right. Left points to 0, right points to I minus 1. So we have this condition. We need to find the sum. If sum is equal to ith number, we just need to return true. If sum is greater, we need to decrement our right. If sum is less, we need to increment our left. So else we just need to return false outside the loop. So let's give it a try and let's talk about time and space complexity. So as we already know, we have this for loop and inside this we have a while loop. So the time complexity is n square and space complexity is constant. So let me try to connect with the internet. So we have solved this question. The code is provided in the description box. If you guys have any doubt, feel free to ask in the comment section. Thank you all for watching.